Hi, my name is Sean O'Kane with Chip Estimate TV, your IP resource for your next chip design in the world of the EDA industry. My guest is Mike Thompson, Director of Product Marketing and Processor Solutions with Virage Logic. Thank you very much for being here, Mike.
It's great to be here. Thanks for having me.
Yeah, we had you at the Design Automation Conference this last summer, and it was a great presentation.
It was a lot of fun.
And for those folks who don't know, tell us a little bit about Virage Logic and what you do, what you offer.
Okay, so Virage Logic licenses intellectual property to semiconductor companies to allow them to take advantage of the IP that we have and focus on the portions of the SOCs where they have expertise.
That's perfect. Mm-hmm. And so what are the current SOC design methodology trends are you seeing that help address the need for meeting really tight delivery windows for designers?
Yeah, so SOCs are becoming a great deal more complex. In fact, very rapidly. It used to be we'd see an SOC typically designed would have maybe 10 or 15 IP blocks on it. Today it's not unusual that they would have 100 or even 150. And as a result, there's a couple things that are happening. First of all, there's a lot more IP components in there. There's many, many fewer blocks that the customers are actually designing themselves. So as a result, they have to go and buy the IP or acquire the IP from somewhere. To do that, it's wise if they focus on a company that's supplying IP and a trusted source. Mm-hmm. Because one of the fastest growing cost components in IC design today, in fact it accounts for about 60% of the cost, is verification. And verification could be an utter nightmare if you don't have good IP, because you'll just get into this endless loop trying to fix the IP. Now, beyond that, in addition, there's a couple components that have become critical in any SOC design today. One is the network. Okay. So the structure on chip that allows them to hook all the different pieces of IP together. Because of the complexity of the SOCs, that network is a critical element in meeting the speed requirements, mm-hmm. timing closure, and just the raw verification of the IC. In addition, there's a lot more programmable elements on there. So tools have become critical, and that primarily is processor tools. In meeting the time goals. And by the way, market windows are shortening. We're getting much more complex SOCs and the windows are getting shorter.
Exactly.
So, this is a huge problem for the guys doing design. And then the other thing that's happening there is a lot more reuse of the IP. So.
Right, that's what I wanted to touch on is reusability and what are some of the benefits and key differentiators that are associated with IP reuse in this landscape, because there is a lot of competitive, partners out there that, that are offering similar, but there's got to be a key differentiator for you. Mm-hmm. What is that?
Yeah, so IP is very clearly very competitive because it doesn't take a lot of effort to. Well, that's probably the wrong way to put it, but it's not too difficult to develop an IP block. What's difficult is to support it, to market it, to put the right infrastructure around it so that a customer can use it easily and reliably in their application. Now, IP reuse has a number of advantages. First of all, if a customer has used an IP block, they're going to be familiar with it. So they've worked through all the initial issues of using it. Second, it's likely built into a bigger block that they have, so they're reusing a whole module, which really just allows them to get the whole thing to market faster with a module that's been verified and tested and been implemented in silicon by them. So there's huge advantages to reuse that allow a customer to get a product to market faster and be more confident in what they're delivering. And in addition, it's likely they can also verify it more easily because they probably have developed test vectors around that block or use test vectors incorporated somehow into their design.
Previously you had spoke about streamlined subsystem approach. That kind of approach combining multiple blocks of IP, and does that make it faster and more economical?
There's no question.
Okay.
Yeah, so I was talking earlier about how critical the networks become in the SOCs. And as the number of IP blocks increases, the network, SOCs are now network centric. and that just happened probably in the last 4 or 5 years. And as a result, because of the way SOCs are being built today, and because of the complexity, the specific point-to-point use case on the SOC or between a couple of blocks can become very critical. You can have real-time needs, you can have bandwidth issues, you can have other issues that play into the communication between block to block that are critical in an SOC today. And because of the amount of IP blocks on there, the only way you can address that is via network infrastructure or subsystem infrastructure. So people today typically are implementing multi-layer bus structures to try to isolate portions of the IC to get critical paths. Where everything's going though is what we call NOC, network on chip.
Is that stacking or not? That's not necessary. That's a totally different.
No, it's totally different.
Okay.
Yeah, no, this is just an on-chip
Got it.
network. But what the NOC does, it allows you to define very specifically point-to-point communication, define bandwidth, define the latency of that bandwidth, how much delay you can tolerate in there by the use case. And that's where all the SOC infrastructure is going. And that'll allow for a much easier reuse, lower power, smaller size, and a much tighter guarantee on the real-time performance of that SOC.
Great. I mean, you said it all. Thank you very much for being here. This is Mike Thompson, Director of Product Marketing, Processor Solutions with Virage Logic, and I appreciate you taking the time. And thank you very much. We'll see you next time on Chip Estimate TV.